On Tuesday, we learn about the matrix and we can print. Okay, so you can see the matrix. You can print the matrix. So let's say this is the matrix. And then you can print this matrix like this one. So if you want to see this matrix in more convenient way, you can have this matrix like this one. So the square bracket, okay, the opening of the square bracket can be in the first line, and then in the last line it will be the closing of the square bracket. And then you can make one list, it is to indicate one row. You can have another list to indicate the second row, and you can have another list to indicate the third row. We can say that this is the row index 0, this is the row index 1, this is the row index 2. And then if we want to access every element, it means this is row index 0 and column index 0. If we want to access this one, it means it is the row index 0 and column index 1. So we can put the word matrix, which is the variable name, and we have two square bracket to indicate that this is a two-dimensional list. So in this case, I'm going to make a loop. So the loop will be from 0, it means from the index 0 until the length of the matrix. We know that if we have the length of the matrix, so we have 1, 2, 3. If we have 0, 3, it means we are going to access the index 0 and then 1 and then 2. Okay, 3 will not be accessed. So I'm going to access the index 0, 1, 2, and then for the column, I would like to access the index 0 until the length of the matrix row. So what does it mean? For every row, at this moment, we have the same elements. So we have 1, 2, 3. We have 1, 2, 3. We have 1, 2, 3. Suppose I delete this one. Is it possible? If I run, then yeah, the matrix will be not in the precise format like 3 multiplied by 3, but the first row we have 3 elements, the second row we have 2 elements, the third row we have 3 elements. So yeah, this kind of format is also possible. It depends on your definition of the matrix. Is it possible if I make this one? Yes, it is possible. So this is a list, and the list is based on your definition. If you want to make more elements in this list, of course, it is possible. That's why we want to know the length of the matrix in the respective row. So if the row equals to 0, then we will check the length of this line. If the row equals to 1, then we want to check the length of this one. If the row equals to 2, then we want to check the length of this one. And then we want to access the row and the column. So the variable row is here and the variable column is here. We will use n with space. It is to print this element in the same line. And then we will print a new line at the end. If you have this kind of matrix, yeah, you will see that the element will be added with the new element 6, 7, 8, 9, like this one. Okay. Now, what we are going to do next is how if we want to sum all the elements. Sum all the element means I would like to check every of this element and then I will do plus. So 1 plus 2 plus 3 plus 4 plus 5 until we plus 9. So we access every element and then we do the summation. So what is the result? In this case, we can define the matrix and then we make one new variable. Let's say this is top. And then we are going to make a new statement, total equals to total plus matrix row column. If we use this statement, then every number will be added. And at the end, we will get the summation. So the final result will be the total is str total. So we are going to print the total. Okay, let's see this result. So I have this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I'm going to sum all the elements. So the total is 45. So the for loop will be the same. The first for loop is to check the row, and the second for loop is to check the column. So if you understand how to make the exam problem in the problem 2, when you do the okay, if you understand how to make this problem, so you can understand what is the meaning by the range in the first part and then what is the range in the second part, then you can understand how you can deal with the matrix. Okay. Okay. We can do the summation even though the number of elements in this case is not same. So even though the length is not same, yeah, we can just look at the length of the respective rows, and then we can do again the summation. So every of the element in the matrix will be added into the variable total. Okay. Now, there may be another kind of variation. We want to sum the elements by column. So I have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I want to add based on the column. So 1 plus 4 plus 7. It will be 12. 2 plus 5 plus 8. So it will be 15. And 3 plus 9 plus 9. 3 plus 6 plus 9. So it will be 18. How can you do this one? So we need to understand how we can access this one, and then we access this one, and then we access this one, and then you do this one. So I give you the code. In this case, I will repeat, or I will do the repetition from 0 until the length of matrix 0. So the length of the matrix 0, it means I'm going to look how many elements do I have in this matrix 0. And then I'm going to check the row. Okay, so this is the column, and then I'm going to check the row. How many rows do I have? In this case, I have, this is 1, this is 2, this is 3. So there are 3 rows. Then I will do the loop from 0 until the length of the matrix. The length of the matrix means we have 1, 2, 3, and then we will do the matrix row, comma, column. Row, comma, column. What does it mean? Let's say this column starts from 0. Now row is in the range of 0 until the length of the matrix. The length of the matrix, we have 3. So we have the row which is 0, comma 0. Okay. The first will be matrix 0, comma 0. And then next we will have the next as the matrix. What is the row? The row will be added by 1. And it means we have matrix 1, comma 0. And then row will be added by 1. So we will go to the matrix 2, comma 0. So the column will be always the same 0, but the row will be increased. After we finish with the 0, we will go to the column 1. Again, we will do the matrix. It is started from 0. So we have 0, comma 1. And then we have 1, comma 1. And we have 2, comma 1. And you're going to put it into the variable total. So this is how we can do the summation elements by the column. There is another problem. How if we want to sum the elements by the row? So I have the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want to do the summation by the row. 1 plus 2 plus 3. Then it is 6. 4 plus 5 plus 6. It is 15. 7 plus 8 plus 9. It is 24. Then how can you make the code? So in this case, yeah, we have this matrix. Okay. So we can find the matrix 0, the summation. Okay. And then we want to start the index of the maximum row. So we can check how many rows are available. And then we start the index of maximum row by 0. So we can do row in the range of 1 until the length of matrix. Wait a moment. I think this is not the max. I mean, L1 by row. Let me check. Oh, sorry. This one is to check which row has the maximum of the summation. So we know that if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, of course, this will be the highest one. This will be the maximum among the other row which we want to do the summation. So the first we'll do the checking. What is the maximum row? So the maximum row will be the first row or the matrix index 0. The matrix index 0 will be this one, 1 plus 2 plus 3. Why we need to do this one? Because we need to have the initial value. We want to make the initial value. After we have the initial value, we will use that initial value to update what will be the next possible row that is higher than the maximum row. So for example, this one. I know that the maximum row is from the index 0. So 1 plus 2 plus 3. 1 plus 2 plus 3 is 6. Okay. Then I would like to check the index of the maximum row is 0. So I just make the initial value as 0. I will go from 1 until the length of the matrix. What is the length of the matrix? We have 1, 2, 3. So we will go until 3. So if we have 1 as the starting and then 3 as the ending, then we will do the loop 1 and 2 on. We will not do the loop on the 3. So the sum of the matrix row, because row start from 1, then I would like to check the summation of the matrix index 1. What is the sum of matrix index 1? It will be 4 plus 5 plus 6. Then I will get 15. Now 15, I will check with the max row. What is the max row? The max row is 1 plus 2 plus 3. which is 6. So 6 is less than 15, or 15 is higher than 6? Yes, because 15 is higher than 6. So we update the maximum row equals to the summation of the matrix row. Then the max row will be now 15. The index of maximum row will be updated. Now it becomes 1. Now we will go to the next loop, because we are going to loop until 2. Now row equals to 2. When row equals to 2, we will do again the summation of the matrix index 2. What is the summation of matrix index 2? 7 plus 8 plus 9, then the result will be 24. 24, is it higher than the maximum row? The maximum row now is 15. 24 is higher than 15? Yes. Then the maximum row becomes the summation of the matrix row 2. Then this will be updated into 24. And then index of the maximum row, it will be updated into 2. And then we will go back again to this loop. This condition, we need to go until the length of the matrix. The length of the matrix is 3. So we will stop, because it will end 3 minus 1. So it will be ended by 2. Then we will get the result is 2. Now let's suppose I have another problem. Let me put this with 9. So what is the result? What is the result of this row? So if I put 9, it means I need to check first the index of maximum row is 0. It means this row is 1 plus 2 plus 3, which is 6. Okay, so the maximum row is 6. And then we have the index maximum row is 0. We will check again the summation of the matrix row, which is started from 1 until 3. The summation of matrix row equals to 1. Row equals to 1. The summation will be 4 plus 5 plus 6 plus 9. 15 plus 9, it will be 24. Okay. So 24 is higher than 6? Yes. Then the max row will be updated into 24. And then the index of maximum row will be updated into 1. So we will go back to this loop. Is it already the length of the matrix? Is it 3? No, not yet. So we will go to the next row, which is 2. In the row 2, we will do the summation again. Matrix index 2. What is the result? 7 plus 8 plus 9. Then it is 24. 24, we will check again here. 24 is higher than 24? No, because there is no equal sign. Then we will not do this one. We will go back to the loop. Now is it already in the tree? Yeah, because now the index is 2, so we finish. Then we will print the row equals to 1. Okay. So with a slightly modification on the matrix, you will get different result. Okay. Now I can also do with something more challenging. I have already the matrix and I want to make it as a random shuffling. Do you know what is random shuffling? So I know that the matrix is 1, 2, 3, 4, 5, 6, and 7, 8, 9. But I do not want to make this sequence. So let the element can be in the random sequence. So 1 can be in this position, 2 can be in this position, 3 can be in this position, and so on. So I would like to make this 2 loop function from 0 until the length of the matrix, and the column will be from 0 until the length of the matrix. And then I will make I and j as any random value from 0 until the length of the matrix, and j is also another random value from 0 until length of the matrix row. I can swap. Do you know swap? So we change the position. Actually, you can think like this one. The matrix row comma column will be the same with the matrix I comma j, and the matrix I comma j will be the same with the matrix row comma column. So we will do this one until all the elements finish, and then we will print the matrix. So if you see this one, the original matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9. But after we do the random sampling, the number will be in the different sequence or in the different position. So you can run again. The number will be in the different position. You can run again. The number will be in different position. So we use the random range. So we want to identify what is the range between a particular value. So I have the 0, which is the starting random value, and the length of the matrix will be the ending of the random value. And also I have this 0 until the length of the matrix row. Okay, so there's one example, very good example to learn how we can apply these two-dimensional lists into one application. So I want to pass this two-dimensional list into a function. Suppose we have a matrix and create a function to pass the matrix into the function argument. So we have pass two-dimensional list. So in this matrix, so now you can start to understand how you can apply the function. Last time I show you to make a kind of structure. Okay. So you can view the structure, and then the structure, you will see that we have three kind of function: main function, accumulate function, and then get matrix function. So the main function will be called, and then the first we will do this one, get matrix. So what is get matrix? This is the function get matrix. So the function get matrix, it is a matrix to this is starting with the empty list or empty matrix, and then you need to fill in how many rows and how many columns you want to create. And after you have the column and the rows, then it will have another kind of input. So you need to input the numbers one by one. After you get the matrix, you can do the product, or you want to make the summation. After you have the summation, you want to print it. So with this kind of function, with this kind of function argument, so you can make several functions, and you can put this one. In this case, I have the accumulate m. Accumulate m means I have a function and I have one argument, and this argument is about the matrix. Okay. Okay, so another application is how we can make a program that creates the multiple choice test. So let's see with this example. I have a function main, and then this is a collection of the student answer. In this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 problems. And for every student, it will be in one row. So this is the answer from student 1. This is the answer from student number 2. This is the answer from student number 3. This is the answer from student number 4, and so on. And I want to check whether the student has the correct answer or not. So I have the key. So it is similar with your learning check. The answer is D. The correct answer is D, but the student answer is A. So it is wrong. The correct answer is B. The student answer is B. Okay, this is correct. The student answer is D, and the correct answer is D, and the student answer is A. So it is not correct. So at the end, you need to know how many correct numbers of the student and how many not correct answers for the student. So we can just use the loop, and then we need to check with the two-dimensional list. So I would like to do the loop until the length of the answers, and then I would like to check how many correct answers. So we will do every elements, and if the answers equal to the key j, then the correct count will be added by 1. So you can do this one. And then you can check. So the student number 0, the correct count is 7. So it means from 10 problems, the student 0 has correct 7 numbers. The student 1 has the correct count 6. So among the 10, there are 6 numbers are correct. And so on. So we can do the loop like this one. We will check the length of the answers. This is the length of the answers. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay. We have 8 answers. And then for every answers, we are going to check on a column. So this is the column. It means we have the A, and then B, and then A, and then C. And then we will check if the answers is correct with the key, then we will add by 1. Okay. Okay, I think I just stop here.